Okay, let's do some math for fun, and today we'll be doing something really fun. We'll be finding the volume of a four-dimensional sphere. This is also called a hypersphere. How does it look like though? I have no idea. And I don't know if we should really call this volume because we are in the 4D world, but yeah, anyways, volume is. For 3D, it's just like a ball, and we can use a triple integral to do so, right, to find the volume. And in fact, if you have x squared plus y squared plus z squared, if this is equal to r squared, that is the equation for sphere in 3D. In fact, if you have 4D, just go ahead and add one more variable, let's say w, and square that. Make that equal, let's say the radius capital R, square that. This will be the equation for the 4D sphere with radius capital R. If you want the volume, some of you guys may want me to put less than or equal to, that's fine too. So we want the things inside. For this, in fact, we'll just be using a quadruple integral, which we have 4, to find such a volume. Let's do it. So v is equal to integral, 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 and then let's do dw, dz, dy, dx. We just have to integrate one, so it's pretty much the extension of the 3D idea. So now, we are in the w world first. Isolate the w, move these three terms to the other side, and then take the plus or minus square root. So the lower bound is negative square root, r squared minus x squared minus y squared minus z squared, and the top is just a positive square root of the same thing inside. And then once we are in the z world, just ignore the w, and then you move these two things to the other side and do pretty much the same thing. R squared minus x squared minus y squared, positive square root, r squared minus x squared minus y squared. And then, you guessed it, this is just square root of r squared minus x squared with a minus, and then this right here, positive square root. And you can recognize that this right here will give you a circle, and this right here gives you a regular sphere, and yeah. And lastly, negative r to positive r. And in fact, it's kind of like a build-up. If you only have one, a sphere on a one-dimensional situation is that it's just like a segment. You have an origin, and then you can go to the left r units, and then go to the right r units. And then if you have a 2D situation, then that is a circle. 3D is a sphere, and 4D is a hypersphere. Do we have 5D and all that stuff? Yes, I will work that out for you guys later on. Yes, we'll be using the gamma function. So, yeah. But now, let's just try to do this with some regular way. So maybe this is just somewhat manageable. I'm just going to work this inside out. Integrating 1 in the w world, plugging, subtract. It's just twice of this function right here. So we will be getting integral, integral, integral. And then inside is just 2 times that square root part. And then dz, dy, dx. So it's not so bad. Here's the thing though. Notice once we did this inner integral, we are in the 3D world. In fact, here we can use a regular spherical coordinate system to help us out. You might be wondering, right here, could we have used the 4D version of the spherical coordinate system? Yes, there's such a thing. That's called the hyperspherical coordinate system. We'll do that in another video. Right here, just do this integral the regular way, and then here we go. The regular spherical coordinate is x squared plus y squared plus z squared. That gives us rho squared, which is the distance from the origin to the point in the space. And then this dv differential, remember dv is like the small change in the volume. I will write down dx dy dz, which is the same as dz dy dx. The order of this doesn't matter. We get rho squared sine phi. And this right here is like the Jacobian. And then you have the differential d rho, d theta, d phi. And the order of this right here doesn't really matter, depends on how you want to set up. And then, of course, I know I haven't put down the limits of integration, but it's just like the negative square root, all that stuff. I just didn't want you to write it down as too much things, and negative r to r. So these right here are right here. So now, what are the things that's going to change? Have a look. We have the integral, integral, integral. Here is 2. And of course, for this equation inside, well, the expression inside is r squared minus parentheses, and then we have x squared plus y squared plus z squared. So on the inside is the square root of r squared minus all that is just rho squared, like that. And then on the outside here, we have all these things, which I will just write this down. We need the rho squared sine phi, and then let's do the differential in the order of d rho, d theta, d phi. I find it super common that people put d phi right here first and then d theta at the end. Technically, it doesn't matter. Now, I'm just going to fill in the limits right here for rho first. Remember, rho is the distance or the radius, right, of the sphere. So what we need is from the origin to whichever the end is, which is just the capital R. So for rho, be careful, we go from 0 to R. 0 to R. dx was negative R to R, but for rho, we start from here and then go to R. Because next, for the d theta, we are going to do one revolution, which will go 0 to 2 pi. And then for phi, which is, this rotation, it's just 0 to pi, we do 180 degrees. So that will just like go from 0 to the radius. And then if you go one loop, and then if you do that, you can get the whole sphere. I'm just looking at from this part to that. Because this and that is a sphere. With this in the middle, right? With this in the middle, that gives us the 4D sphere. Okay. Now we are going to break this down into 3 little integrals because they are really nice. They all converge. So then there's no improper integrals or whatnot. Not bad at all. So I'm going to have the integral here. And the hardest one is the rho one because we have the rho square, all that stuff. So I'm going to put down the integral from 0 to r, and then 2 rho squared times square root of r squared minus rho squared in the rho world. And then we multiply by, let's do the theta next. Theta, I will just do it in red. Integral from 0 to 2 pi d theta. And then lastly, we multiply by the integral from 0 to pi sine phi d phi. Alright, we just had to work this out, work that out, and work that out, and that will be it. Okay, so for this integral, notice that we have a constant square minus the variable square in the square root. And on the outside, it's rho squared, the variable square. So u sub is not enough. In here, we actually have to do trig substitution. So this is just like a good old calculus 2 integral. So this is what we'll do. I'm going to take rho equal, we need a constant r, and then we are going to use the sine function because we have the constant square minus the variable square. I'm going to use t because earlier we used the theta already. And then go ahead and differentiate that. It's r cosine t dt. And remember, these are the rho values. So when we go to the t world, if rho is equal to 0, put it here, sine of what will give us 0? Well, 0. So t will be 0. And then if rho is equal to r, then we are looking at r is equal to r sine t, meaning sine t has to be 1, and just take t equals pi over 2, which is the first answer that will give us 1 for sine, so pi over 2. And then go ahead and just do the rest. 2, rho is that, so it's r sine t squared times the square root r squared minus rho, which is r sine t squared. D rho is r cosine t dt. Whew. Now let's go ahead and simplify that. 2 can be put all the way in the front, and we have r squared. Let's also put that all the way in the front, and then we have the integral 0 to pi over 2. And we'll finish everything in the t world. At the end, we just get some values out of this, so yeah. And then here we have sine squared t. But notice, this right here, we have r squared, so we can factor that out. And then we get 1 minus sine squared t. And notice this is in the square root. Take square root of r squared, we get another r. I can put it on the outside. Square root of this is just what? Cosine square. And then we'll just cancel the square root and then the square. So we get cosine here, t for the blue part. And then this r, in fact, we also have to take it on to the outside. So that will be r to the third power. So 2 of them from here, 1 more from here. And lastly, we have the cosine t multiplied with this. So I'll make that second power. Okay, so far so good, huh? And then let's just go ahead and do it. Firstly though, that's 2r to the 4th power. How do we integrate this? We'll be using more trig identities. First, notice that this is the same as sine t cosine t squared. And this right here, we can use the double angle identity for sine. Rewrite it as 1/2 of sine of 2t. And then square that. And that will be, of course, 1/4 and then sine squared 2t. Okay, not done yet. Because the 1/4 stays, if you want to integrate sine squared, you have to use the reduction formula for the power. And let me just remind you guys, sine squared of theta equals 1 minus cosine of 2 theta divided by 2. So here, our angle theta is the 2t. So do this, we have the 1/2 times 1 minus cosine of 2 times our 2t. Okay, so this right here will give us over 8. And then the rest, right? Integral from 0 to pi over 2. And we have the rest, they have to stay inside. 1 minus cosine of 4t dt. Okay, reduce all that so we get r to the 4th power over 4 and then put on parentheses for the result of integration. So integrating 1 in the t world, we get t. Integrating negative cosine, we still get negative, but sine 4t stays. But remember, we have to divide it by the derivative of that, which is just a constant. So we can do this because it's just a constant. And that's pretty much it. And then we go from 0 to pi over 2. Now, when I'm plugging pi over 2 into t, that would be pi over 2. So we have r to the 4th power over 4 times pi over 2. When we plug in pi over 2 into here, that will be 2 pi. Sine of 2 pi is 0, so bye-bye. Plugging 0 into here, 0. Plugging 0 into here, 0. So guess what? That's all we need. And then altogether, I'm just going to write it as pi times r squared over 8. So that's the result for that integral. Now let's go back to what we had earlier. Okay, so as we saw earlier, this right here gives us pi times r to the 4th power over 8. And then for this one, integrating 1, plugging 2 pi, plugging 0, you'll just end up with 2 pi. Lastly, if you integrate sine, you get negative cosine. Plugging pi, you get negative 1 because of cosine pi is negative 1, which you get positive 1. Minus negative cosine of 0, which is minus 1, which is plus 1. So 1 plus 1 is 2. Alright, so altogether, if you work that out, that's 4. Divided by that is 1/2. And then pi times pi, we get pi squared. And lastly, we have r to the 4th power. And ladies and gentlemen, this is the formula for a 4D sphere with a radius of r. That's it.